Algebra 2, set 91, linear equalities, greater than or equal to, less than or equal to, and systems of linear inequalities. So a line divides all of the points on a plane into three disjoint subsets. So that means you have three different sets. They're not necessarily overlapping at all. That's what disjoint means. They don't overlap. And you have different subsets. So the first subset is all the points that are on the line. And then the second subset is all the points above the line or to the left of the line, depending on what the line looks like. And then the same thing on the bottom, all the points below the line or to the right of the line. So let's look at an example. If you have the line y equals negative 1/2 x plus 1, you have lots of different points that could be above the line. So for example, 2, 4, 4, 5, 5, 2. Now those points are not on the line, those points are above the line. So we have two different inequalities to represent whether it's above the line or below the line. In this case, the points above the line are going to be represented by the greater than sign. So in order to check that, what we can do is take one of those points and plug it into the inequality to make sure that it is true. So we'll take the point 2, 4, and we'll plug it into the greater than inequality. So we say 4 is greater than negative 1/2 times negative 2 plus 1. And then we just solve it. 4 is greater than 1 plus 1. So 4 is greater than 2. 4 is greater than 2 is a true statement. So we know that that is a solution for y is greater than negative 1/2 x plus 1. Let's try another point, the point 4, 5. So we have 5 is greater than negative 1/2 4 plus 1. So 5 is greater than negative 2 plus 1. 5 is greater than negative 1. Again, a true statement. So that is true for y is greater than negative 1/2 x plus 1. We'll do one more example with the point 5, 2. So negative 1/2 times 5 is negative 5/2. 2 is greater than negative 3/2. That is a true statement, so those points are true. Now we could do the same thing with points below the line, but we're not going to take that much time. So anything that's below the line is going to also be able to be plugged in to the inequality y is less than negative 1/2 x plus 1. So if it's greater than, it's above. If it's less than, it's below. Okay, so here's a different equation. Y is less than or equal to 1/3 x plus 2, and y is greater than 1/3 x plus 2. So since we have less than or equal to, the solution is going to be below, and if the inequality is greater than, the solution will be above. So we graph the line, and we know the solution is going to be below, so we shade in below. And the second one, same thing, we'll graph the line, we know the solution is going to be above. Now I need to make a note about the lines. Since we have the less than or equal to symbol, we know we're using a solid line. And when we have the greater than symbol, it doesn't have an equal with it. It's going to be a dashed or a dotted line. Okay, so let's look at a couple of examples of shading. So you have two lines, y equals 1/2 x minus 1 and y equals negative x minus 2, and they divide the plane into four portions, A, B, C, and D. So we have a dashed line and a solid line, and for part A, in relation to the dashed line and in relation to the solid line, we can see that A is above the dashed line and it's above the solid line. When we look at letter B is below the dashed line and it's also below the solid line. For part C is below the dashed line, but it's above the solid line. And then part D is above the dashed line and below the solid line. Okay, looking at these relationships is going to help us know how to write our inequalities. So for part A, we can use, since it's above the solid line, we're going to start with the solid line. Y is greater than or equal to 1/2 x minus 1. So we're looking at the solid line, it's greater than or equal to. And then the dashed line, it's not going to have that equal to symbol with it, and it's above it, so it's going to be y is greater than negative x minus 2. For part B, we're looking below and below. We have a solid line and a dashed line. So for the solid line, it's going to be less than or equal to. So y is less than or equal to 1/2 x minus 1. For the dashed line, it's going to be less than negative x minus 2. For part C, now we're getting a little trickier. We're above the solid line and we're below the dashed line. So when we look at that solid line of 1/2 x minus 1, we're above it, so it's going to be greater than or equal to. So y is greater than or equal to y is greater than or equal to 1/2 x minus 1. Now we look at the equation y equals negative x minus 2, and c is below that, so it's going to be less than. It's not less than or equal to, it's less than. So y is less than negative x minus 2. And our last one, D. When we look at D related to the solid line, it's less than or equal to 1/2 x minus 1. And then when we look at it compared to this dotted line, it's greater than negative x minus 2. Okay, in this case, we have two different lines, and we're going to do the same thing. We have a dashed line and a solid line, and we have letters E, F, and G. In this case, we have two parallel lines. It's still divided into different parts, but in this case, instead of being divided into 4 different segments, we've got 3 different segments. So, looking at letter E, E is above the dashed line and it's above the solid line. Letter F is above the solid and it's below the dash, so it's below and above. And letter G is below both of them. So when we go to write our inequalities for letter E, E is greater than 1/3 x plus 1, and it's greater than or equal to 1/3 x minus 1. And again, we're getting the greater than symbol because of the dashed line, the greater than or equal symbol because of the solid line. Okay, letter F, when we look at the dashed line, it's less than, not less than or equal to, it's less than 1/3 x plus 1. When we look at the solid line, it is greater than or equal to. Y is greater than or equal to 1/3 x minus 1. We look at part G. Part G, it's below both lines, so it is less than 1/3 x plus 1, and it's less than or equal to 1/3 x minus 1. Okay, graph the solution to these two equations. So the first thing that you need to do is you need to graph the lines. So the first thing I see is I've got a y-intercept of 2, and it's a less than, so I'm going to be graphing a dotted or a dashed line. So I'm going to find point 2 for the y-intercept, and then my slope is 1/2, so I'm going up 1 and over 2. So up 1 and over 2, mark those points, and then I have a dashed line. Okay, now for the next line, my y-intercept is -3. It's greater than or equal to, so it's going to be a solid line, and my slope is -1, so I'll be going down 1 over 1. So then I can fill in my line, and then the last thing I need to look at is what is the relationship here. So for the first one, it's below the line, it's under, it's less than, so I'm looking at everything less than the dashed line. And for the second one, I'm looking at everything above the solid line. And the solution is what's going to be true for both. So I'm looking for the section that's below the dotted line and above the solid line. And the section that satisfies both of those qualities is this shaded portion right here. Let's do another example. graph the solution to y is greater than x minus 2 and y is less than or equal to x plus 1. So the first thing again that we look at, I have a y-intercept of negative 2 and it's greater than, so it's going to be a dashed line. So y-intercept of negative 2. My slope is 1, so I'm going to go up 1 over 1. And again, it's going to be a dashed line. So for the second part, I have a y-intercept of positive 1. It's going to be a solid line because it's less than or equal to, and my slope is 1. So I'll start at 1 with a slope of 1 and do a solid line. Okay, for the first graph, I'm looking at everything over or everything above, and the second graph, I'm looking at everything under or below because it's less than. I'm looking for where they intersect or where they overlap, and they overlap at this point right here. So that is the solution of my graph.